Welding a joint doesn't just fuse metal, it leaves behind residual stress and a hardened, brittle zone right next to the weld. PWHT exists to undo both, before that vessel ever sees pressure. Welcome back to ASME Section 8 Division 1 in 5 minutes. Episode 6, Post-Weld Heat Treatment. UCS-56 starts from one default: every weld in a pressure vessel gets post-weld heat treatment. Not most welds, every weld, unless a specific exemption applies. That's a stricter starting point than a lot of engineers expect. The exemptions themselves live in 11 separate tables, UCS-56-1 through UCS-56-11, one for each material group, and each table sets its own thickness threshold below which PWHT isn't mandatory. For ordinary P number 1 carbon steel, that threshold commonly lands around 5/8 of an inch. Thinner than that, you are often exempt. Thicker, PWHT applies. But thin metal doesn't always get you out of it. UCS-56 explicitly overrides its own thickness exemptions when PWHT is a service requirement. Sour or wet etch, though as service under UCS-68 is the classic example. In that case, it doesn't matter how thin your material is or what the table says. The service condition wins, and PWHT is mandatory. The same override applies to certain electron beam and friction welding processes. Always check service requirements before you lean on a thickness exemption. So what's actually happening in the furnace? 3 phases, tightly controlled. Heating. Above 800 degrees Fahrenheit, the rate is capped, generally scaling down as material gets thicker, so you don't shock the metal. Soaking. The vessel holds at the specified temperature for a specified time. This is what actually relieves residual stress and tempers the weld's hardened zone. And cooling, also rate limited above 800 degrees Fahrenheit, typically in a closed furnace, before finishing in still air below that point. Uniformity matters throughout, no more than about 150 degrees Fahrenheit difference across the section being heated. Here's a field-relevant detail: if you find a defect after PWHT is already done, you don't automatically need to rerun the entire heat treatment cycle. For certain materials, UCS-56.7 allows a temper bead repair technique, controlled electrode size, preheat, and a final tempering weld layer that tempers the heat-affected zone as you weld, without a full furnace cycle. It's tightly restricted by material type and repair depth, and it still needs inspection and a hydro test afterward, but it can save reheat treating an entire vessel over one repair. Why does this all matter beyond the paperwork? PWHT is often the single biggest schedule and cost driver in a fabrication job. Furnace time, thermocouple placement, controlled heating and cooling can take a full day or more per cycle. Get that thickness or material call wrong, and you've either skipped a mandatory step or wasted a furnace cycle nobody needed. Getting the UCS-56 table lookup right, before welding even starts, is one of the highest leverage checks a car engineer can make on a job. Quick recap: UCS-56 defaults to PWHT for every weld, with material and thickness-based exemptions in 11 tables. Service requirements like sour service can override any exemption. And even after PWHT, repairs don't always mean starting the whole cycle over. That's episode 6. Full table thresholds are linked below on Weld Fab World. Subscribe. Episode 7 covers nozzle and opening reinforcement, and the area replacement method.